Hello everyone, today I'm going to make a video to explain what is SSL and certificates. Before I start, I would like to quickly clarify this video is made for software engineers, not for security experts. The reason for that is when I was learning new languages or new knowledge or some new things, so I found it's really hard for me to get a very high level idea about what those things are. Um, I can find a lot of documents. They all like very detailed, but doesn't give me enough things as a software engineer to enable me to do the job. Yeah, because when I was doing stuff, so if I facing some new things, I see is I can actually I can actually ignore it and just do my job, but that thing will work as magic, black hole or black hole. Um, I just don't feel like scaring of making mistake and very stupid mistake. So if I understand a little bit about how it works, what it is, so that will help me a lot. So that's the reason I make this video, to give you the confidence around those topics so you can do your job confidently. Yeah, so today's topic is SSL and certificates. This is about HTTPS. So, so maybe 20 years ago, when you access a website on IE, so you may access just to use HTTP / www.bank.com. So you access a website like this. But like 20 years later now, most of the websites, when you access them, you're gonna use HTTPS. So that's S for security. How they do security? They use SSL. So they actually encrypt everything before they send out the data out from your application or website or web page or your computer, and then decrypt it when the message or the data landed on the server side. So this is for making sure your data is not hacked by anyone or received on a hacked and read or modified by anyone on the internet. So only the sender, which is you, and the server side, which is the bank, to receive. SSL is the technology we use to encrypt and decrypt. Okay, and certificate is another thing, nothing special, nothing magic, but it's on top of it. I'm gonna introduce you that in detail in the following slides. Don't worry about that. But before we start, I will actually quickly introduce two algorithms. So because they are very fundamental things, without them we will not be able to explain SSL very easily. The first one is a algorithm, encryption decryption algorithm called symmetrical encryption. The key for that is the key point of this algorithm is using the same key. Yeah, you may confuse. Sorry, if I don't explain the background, you may confuse. So security. What we are talking about security is it the security we are talking about is to make sure two people are talking to each other. When they are talking to each other, the message they're sending is secure, is encrypted, and not spied by anyone, can't be received or modified by anyone. So it's one side to another side, right? So to do that, before we send out from one side, we will encrypt it. We'll encrypt it, and the receiver, before receiver actually do anything to understand the message, it need to decrypt it to the original message and do handle the message. So that's why in the whole conversation we have like one client, another client, one sender, another one is the receiver. And then the key thing is, before we send out the actual message, we'll need to encrypt. So this is what I am showing you on here. So I have a client side, we have a server side. Don't have to be client side and server side. could be two-person or peer-to-peer, doesn't matter, but this is just an example, and this is a common way to do that. SSL as HTTPS. So you are the website accessor, and this server side is a website provider. So before you send out, we use the encryption to encrypt the data. But the thing is, encryption algorithm won't be secure enough if it's not using a special key, and special key only you and the server side knows. So that will make sure the data can be encrypted with a special way, with a special key, and not easy to be decrypted by anyone else, because encryption algorithm is more or less public. Everybody know there are number of different algorithms, but key can be different. Okay, so the server side and client side will use the key, but how we get the key? Okay, normally there's three ways. One is someone generates a key, okay, and the key will be sent to client side and server side, and then when they decrypt and encrypt, they'll use the same thing. They'll use the key. Or client side generates a key and send to server, or the server side generates and send to client side. The most important here is the key will be transferred from one place to another place via the internet, which is kind of danger zone. Okay, so this is one of the things you need to keep in mind, because we're gonna use this and discuss this a little bit later. Sorry, excuse me. Yeah, so let's see how it works. So we got 1, 2, 3 to send from client side, and that data will be encrypted by the key and the algorithm. And the output from that is a sort of like something looks like rubbish. You can't really read it. You don't really know what is actual data is. That's an important thing. And the data will be transferred or will be sent via internet, which is sort of a danger zone, because anyone on the internet can actually potentially get and access the data, grab the data you're sending. However, the message they got is sort of rubbish. They can't decrypt it and get the actual data on top of it unless they have the key. Okay, that's how the server side get the actual message. So the message will be landing on server side. Server side will first decrypt it and then get that message, and the server side can process it. So the key point is before we send it, we'll encrypt it. So anything left your computer and before the server is something sort of unreadable. It's sort of rubbish. Nobody can understand what is that. That's the whole idea about this encryption. And the key point of a symmetrical encryption is about we're using the same key. Okay, if you don't really understand, I would like to use a real life example to explain how this works, because it's very fundamental. If we don't really understand how it works, we can't go move forward for the next topic. So for example, in the real life, there's a person called Peter wants to send something to some guy called Alex, and usually they will use a security team to call they will call a delivery company to send thing. For example, they have a notebook. Okay, they put Peter send the notebook put into a box and call delivery company, and the company will send the box to Alex. But the problem here is after Peter handed this to the delivery company and to Alex got the box, there's so many people can actually potentially touch the box and unbox it and read through the notebook and make another fake box and then wrap it and put it back to Alex. Alex won't know if someone read it or changed it. So Peter and Alex really concerned about this way. And then Peter found a way. So Peter bought one of this, a safe. To open that, you need a passcode. So after Peter bought it, Peter set up a passcode on this, and then Peter called Alex and shared the passcode. So now only Alex and Peter knows the passcode. So Peter then put his notebook into this safe and lock it and call the delivery. Delivery then send the safe to Alex. Alex used the passcode he got and opened the safe and got the book. So you see the danger zone here is out of Peter's door and between before Alex actually received the safe. That's the danger zone. So anyone can touch it. Anyone can touch it, but they can't open it because they don't know the passcode. They don't know the password. So this is how this symmetrical algorithm, symmetrical encryption algorithm works. It's using the same key, and then it locks a message, and only the receiver can unlock the message and read it. Hope that makes sense. Okay. This is how it works. Peter, put things into locker, use password to save it to lock it, and then the password shared with Alex before that, and Alex can open that save by the password and see the extra message. Okay. There's another algorithm apart from that, so which is asymmetrical encryption algorithm. So that algorithm used two different keys. So the key difference here is this algorithm used two keys. Previous one used one key. So these two keys, how this works. So similarly, the client side used the green key to encrypt 1 to 3, and that encrypted into sort of rubbish, and then this rubbish message has been transferred by the internet and landed on the server side. And server side decrypts message by the red key, and then get the message 1 to 3 here. Okay. The key point, there's two things I want to highlight here. One is they used two different keys, and these two keys can only be used to send a message from this way to this direction. Okay, this direction to this direction. You can't use the same red key to encrypt and send to here and let this guy to decrypt. This won't work. So if you want to send this back, you need another pair of key to do that. Okay, but you need another pair of key. So that's why we have a new algorithm called RSA. RSA solves the problem. So RSA will make sure you just use the same pair of key. Again, not the same key, just a pair of key, two different key, green key and red key. So green key can be used to encrypt the data, and red key can be used to decrypt the data. And the red key can also use to encrypt the data, and only the green key can decrypt the data. Okay, I would like to highlight only. So message be encrypted or locked, I will just call it a locked. Message which is locked, I'll use the example as I mentioned in the save in the previous one. The message which is locked by the green key can only be opened by the red key. Okay, the message which is locked by red key can only be opened by the green key. Okay, that's how it works. So we got 1, 2, 3, and then before the client side sent to the internet, it will encrypt it by the green key. So the message here, the rubbish message, is a kind of a green key encrypted and then sent to server side on the internet, and the server side receive it will decrypt by the red key, and the server side get the actual message with 1, 2, 3. And then the same way, 1, 2, 3 can be encrypted by red key, and this message can be decrypted by the green key, and then client side will receive the message which server side sent to. Let's quickly go through this again here. This is very important. I just want to make sure this is the danger zone. I just want to make sure this is not easy to be hacked by someone. It's not hackable. Not only easy, it's not hackable. Okay. So the message is encrypted by the green key. As I mentioned, only the person who gets the red key can decrypt it. Who has this? Only server side, nobody else. Okay, that's why that can be sent to here. That's securely. Back to this one. This is red key encrypted. Only who can decrypt it? Only this guy, because only this guy has a green key. Okay, that's the key thing. Keep in mind, because we're gonna use that knowledge again. Okay. So now I'm gonna use those things we learned to explain how the SSL works. As I mentioned, SSL is just a security top of like kind of security technology set on top of HTTP. Okay, this is used to encrypt and decrypt data before you send out. So how it make sure um, the data has been created securely and nobody can hack the data. So it's used the technology and algorithm I explained. Okay, let me explain that. So first, the client side send hello to server when you access www.bank.com. So you send the hello to the bank, which is the server side, and then bank send you a thing called public key. What is public key? This is a new thing. I didn't mention that before. It's a new thing, but it's not really new. It's just that this key, this green key here. Now we call it differently. We call it public key, and the red key we call it private key. Right? Why we call it public key and private key? The reason for that is because we're gonna share the public key to the people who actually access the server. Every time people send hello, the server side will reply the public key. But the private key will be always stay on the server side. So later on, we'll find out the public key will be on the client side, the private key will be on the server side. Same as before, green key here, red key here, though they can talk to each other using those two keys to encrypt and decrypt data. Right, so once you send hello server side, send the user the green key, which is the public key, and then client side encrypt the data 123, which is the user account, and then ask the server side to tell the client the balance of the client, balance of this account. So 123 will be encrypted into kind of rubbish, and this data will be sent to the server side. Server side decrypted, get 123. It's nothing special, similar as we discussed before, introduced before. And then server side will query the balance for the user and then get £8. And £8 will be encrypted. The number, the message will be encrypted by the red key and will be sent to the server client side. The client side. The client side will then decrypt the message using the green key into £8. Looks good, right? Looking good. And now, just as you say, do you think that's safe enough? Because this is the danger zone here. Okay, this is danger zone here. If I have a hacker, can get anything on this danger zone. So that's why we want to quickly verify if this is secure enough, Can anyone else apart from these two parties to access this? Let's see the green key encrypted message. As I mentioned before, green key encrypted message can only be decrypted by the red key. Who has a red key? As mentioned, this is a private key. Never leave this server side. So nobody know, only the server side know that. So that means nobody else can decrypt it. So that's good enough, right? That's secure enough. However, how about this one? So as mentioned, this is red key encrypted. So green key will be able to decrypt it. But who has a green key? As I mentioned, it's public key. Anyone access the server side will be able to get the green key. So anyone can decrypt to get the message. So like a hacker can grab the message, right, from the internet, and the hacker can access server side to get the public key, right, and then decrypt it by the algorithm. So hacker get the message. So which is not good. So how to solve the problem? We just need to combine these two algorithms, the symmetrical algorithm and the asymmetric algorithm together to solve the problem, right? So at the very beginning, we'll still send the server hello, and server side send back the public key, right? Public key, I already know, as you know. This is a concern we have, okay? But we can still use the public key to send anything to server with very secure, guaranteed way. So which means we're gonna use, but however we can't send this back downstream. So to make sure the downstream is secure enough, we introduce the symmetrical algorithm. Client side will create a key. Do you remember Peter shared the key with Alex? So Peter will create the key, and the key will be encrypted by public key, because as I said before, this is secure enough, so nobody can hack the message. The passcode will be shared with the server side. Server side will get the passcode by this key decrypting the message, by using this key to decrypt the message. So this guy got the key, this guy has the key as well. So after that, the client side can send the message with this key, and then the server side will receive the message, and server side can also encrypt the message and send back to the client side. Okay, as we did before, we're gonna quickly review message on this danger zone. So this is already checked. There's no problem with this message here. But how about this message? So this message has been encrypted by this pin key. Anyone can decrypt? Only per people or client who has this pin key, because this pin key is created by this guy and shared by this guy. Nobody know, and when they are transferring, nobody are able to hack that message. So nobody know, only these two parties. So which means that the way we designed now is secure enough. And this is actually how SSL works. So far, everything's okay. You don't need to know much more about SSL. Okay, and this is how SSL works, about encryption, decryption with public key and private key. However, that server side can be a fake server side. So which means this could be a fake www.fakebank.com. So it looks exactly same as the bank.com website. So people can log in and put users and password in, but actually the hack behind the fake website receive the password username and they go to the actual website and take all of the money from the user. Okay, which is not good. So that's why the certificate kicks in. Again, this is about certificate, right? If you just want to understand how SSL works, the first one finished. Okay, now this is the next level to make this SSL more like reliable. When I say reliable, I mean when you talk to someone, you know you're actually talking to someone. You're actually talking to that guy. When you're talking to Alex, you're sure you're talking to Alex. It's not fake Alex. Okay, that's certificate helps us to do. Okay. To do that, at the very beginning, the server side. Okay, I removed all of the detail communication down here. So we just need to focus on the very first step. When you say hello to server side, it gives you something different. But before that, the server side, before the server side go online, it need to create a certificate. How they create a certificate? The server side will go offline and talk to someone called CA. It's a certificate authority. It's a third party. It could be company, could be organization. They will verify. Okay, the server side will say, I'm the bank.com. Can you give me a certificate? And the CA will ask them to prove, for example, your company registration, everything, bills or whatever, to prove you actually is the bank.com. Okay, after this is all carefully verified, and then CA will be able to issue them a certificate. Instead of a certificate, CA will put their public key, so the server side public key, into that certificate. What is certificate? Certificate is kind of like envelope, and on top of the envelope, CA puts a stamp. So the stamp belongs to CA. It's the name of CA. People who see the stamp and know the CA will know this is something proved by the CA, and people will trust it. Okay, and as I mentioned, this envelope will be deployed on the server side, and then when the client side access the server side will then send the envelope to the client side. As I mentioned, inside of envelope it has the green key. And then the server side will then open the envelope and use the green key to do following communication as the SSL way I mentioned before. However, there's one thing I I didn't tell you in detail, we explain in detail, which is once you got the envelope, you just use the green key? No, it doesn't solve the problem, because if you just open the envelope, you don't check the envelope, you don't verify if this is something trustable, you're still facing the same problem. You can access the fake bank.com. Okay, how the client side verify that? Client side will then check the stamp. On the stamp, it will say, okay, is this public key is verified by XXCA, the CA name called XX, verified by XX, and we can confirm the public key belongs to bank.com. If you're connecting to bank.com, you are using the right key. You are talking to the right person. Okay, and then the client side can trust it and do the following job. However, how can I know CXX is trustable? How can I know XX is someone trustable? I'll give you an example. Okay, this is some. For example, this is Alex. Alex come to you, say, "Hi, I'm Alex. I'm come here to get my wallet back. This wallet belongs to me. Yeah, you actually expecting someone like called Alex to fetch their wallet, but you don't know the person in front of you is the real Alex or it's just someone else. It's not the real Alex. So you tell Alex, you say, you prove yourself. Alex say, no, I don't, I can't prove. That's what we are facing previously. And then Alex just and then we got the certificate. Okay, the CA kicks in. So then Alex finds someone called Bob and say, and then Bob made a letter and say, read something on the letter saying, anyone who see the letter, and I can confirm the person in front of you is Alex. Okay, and you got the letter, and then Alex came back, and then show you the letter, and you read the letter. I say, oh, there's someone called Bob. Confirm this is Alex, and you confused. What? I don't know you. I don't know you. I don't know Bob. Why I trust Bob? You give me the letter. I don't know. I don't even know who is Bob. Why I trust Bob? You give me the letter? No, this doesn't work, right? So that's exactly the same as we mentioning here. So XXCA issued the certificate, and you got the certificate. You say, okay, this stamp here saying this is from this is verified by XX, but you don't know XX. You don't trust XX, right? So you can't trust this public key as well. Neither either. So how to solve this? So you need to tell Alex, back to the example. You tell Alex, say, Alex, you go to the post office or you go to the police station, ask them to verify and write a letter for you. And Alex went there and get a letter and send you back. And then once you see the letter saying this is Alex, okay, you confirmed. Okay, you can give the wallet to Alex. Okay, and this is how it works, right? And back to our actual thing. Similarly, so a server side can't just go to someone called Bob to get the certificate, okay? Because the certificate is very easy to create. It's just an envelope, as mentioned. I just put something into an envelope. It's just a piece of paper. Everyone can generate this kind of thing, okay? Bob can do this, okay? Alex can do that himself as well. So we need to have someone which is trustable. So police station in the real world is the trustable organization to issue that. In our computer world, we don't have such thing. We don't have police station. Okay. In our computer world. So how it works? Okay. In computer world, we have numbers of very good reputation companies. They are CA. Okay. They never make rubbish things. Okay. You never can pay £100 million to make a fake certificate for Barclay, for example. Okay. No, they never issue you that. They can't. They will never do that. That's why they called good reputation, trustable CA. Okay. who issued them the name Trustable CA? Those big companies issue them this name, issue them this label. They are Apple, Microsoft, and Google. Okay, they actually have agreement or whatever, so they Google and Microsoft believe them, and then Google and Microsoft and Apple pre-installed those companies into our computer. Okay, put their names pre-installed into our operating system. So, which means the client side, once the client side received a certificate and found out on top of a certificate it has a stamp from XXCA, for example, and then it will then go to something called root certificate. It's the pre-installed, pre-listed list, as I mentioned before, and then it will go and find out, do we have XX in the list? If XX in the list, and then which means it's trustable. So there's no such PlayStation there telling you this is a good guy. Only Microsoft and Google and Apple tell you this is a good guy. Well, it's up to you. You may think, no, they're not trustable, but you have no choice, right? They're supposed to not be evil, right? So they pre-installed CAs. They pre-installed the CA name list into your computer. Again, this is something a little bit complicated. It's not name in the real world. It's their certificate. But I don't want to confusing you. I'll just call it CA's names in your computer has been pre-vet listed in your computer. Okay, by Microsoft, by Apple, by Google. Right, and then once you see a certificate, you say, oh, that certificate is issued by those companies, you then can trust it. Okay, you then can use the public key to do your following conversation. Okay, here this is one thing I want to mention here. I want to add here. So as mentioned, you can be the CA yourself. You can issue the token. You can issue the certificates. But nobody will trust you, right? Only yourself can trust yourself. Okay, this sounds like stupid, but this is useful. So for example, you have a company, you have 100,000 computers, right? When you want to use SSL, HTTP to make sure they communicate each other like undeniable or talking to the right person, okay, trustable, you don't have to get a certificate from the public CAs because it's not free. If you ask a certificate from them, they will charge you. So you can issue the certificate and you can be the CA yourself and reissue certificate for all of the computers in your company. But you need to make sure you have your name pre-installed into your computer. Okay, so this is how your IT need to do. Your IT need to install your name into your computer, into all your computers, belongs to all your company's computers, and then they can use this free certificate issued by you. Okay, I think that's pretty much I want to say about certificate and SSL. And here is the final version. Let me quickly go through that with you. So first, when the client side calls server side, it will say hello, and server side will then send the certificate back to client side. Okay, and client side will verify the certificate to see if this is trustable certificate. If yes, okay, and then it will extract this green key and use this green key to encrypt another key which is generated from here, from the client side. And the green key will be used to encrypt this key and then send this message to the server side. So this message is the encrypted pink key, and then that message sent to server side decrypt it, and the server side will get this green the pink key, which is the password you shared with Alex, as the example I showed you. So this is the password only known by you and the server side. And then After that, client side can send a message which is encrypted by this purple key or pin key, and then share with the server side, and server side can decrypt it, and the server side can also send a message to the client side by encrypting the message with the pin key. So that's all I want to share with you about SSL and certificate. The key things, labels in this video are public key, private key, RSA, symmetric algorithm, decryption, encryption algorithm, asymmetrical encryption, and certificate and CA. So actually this video covered all things you need to know about those labels. As an engineer, that's enough for you. Hope that makes sense. Thanks for watching.